All right, so what we're going to walk through today is the quadratic formula. That's our primary goal. We're also going to do a number of review pieces that we've woven in intentionally into this. So, on our calculator, back a couple, maybe a week or so ago, we talked about how to find the zeros. And so what I want you to do is go to your calculator, and I want you to put this equation in, 3x squared minus 4x minus 2 into your calculator, into the y equals function. We're going to walk through this together up on the screen as well, but I want you to do this with me. All right, so 3x squared
How do you set it equals 0?
equals 0. No, just y equals 3x squared so 3x squared minus 4x.
Wait, is x squared?
Wait a minute, mine's squared the wrong thing, sorry.
I thought we were putting in 3x squared minus 4x.
You are. Put in what's on the board and what's on your screen. My computer's being a little bit funny. All right, so that's what we should have in.
22?
No, 2. My cursor's being a little funny. All right, so that's what we should have in. 3x squared minus 4x minus 2. Now, do you remember what zoom function is our general
6
function? Okay, so go to zoom 6. And that's going to give us our general diagram that's 10 by 10. Now on this general diagram, I have chosen to put dots on my graph to allow me to see perspective a little bit more. If you would like to have dots on your graph, the way you get those is go buying second zoom, which is format, and down here on this line here, the third line, you have grid on and grid off. And grid dot is what you would hit enter on in order to have the grids on here. So then you can pick what color you want your grid. I like blue just because it shows up very clearly on my graph. So that was on second format. I don't know if you have grids on that one or not. So anyway, all right. Now, that's a little bit broad picture. I would like to zoom in a little bit. And so the best zoom feature that we have is the option decimal, number 4. So we're going to select that. And so there we have zoom option 4 for decimals. And that just gives us a little bit smaller window. Now our purpose here is to try to find this point where my cursor is. That spot right there on the x-axis where the parabola crosses the x-axis. Now to do that, we're going to use a left bound and a right bound. Now to get those points, and let me clear out all these steps to allow you to see my steps down here at the bottom on a new cycle. Go second, trace, which is the word calc. Choose option 2, which is 0. And now the question at the bottom of the screen says, what is the left bound? And so our left bound, we want to take our little cursor and we want to move it along the parabola so it is left of the x-intercept. So my cursor sitting right now is pointing at the x-intercept right down here, and we want this little spider, whatever you call it, to the left of it. It really doesn't matter how far left you are, so long as you are a little bit left. In this case, that also translates to above. Once you are left of the x-intercept, hit enter. And a small dotted line will appear along with a tiny little arrow up at the top that is pointing to the right. You see this little arrow up here?
Wait, I'm confused on where, like the whole left of the...
See this spot right here?
Yes.
Okay, we want the cursor, the x value, to be left of that. So you just arrow to the left of it. So now I'm going to do the second one. So watch right here. Now I want my cursor. See, my cursor is moving. So now let's see how now my cursor is to the right of the x-intercept. So here's the x-intercept, and my cursor, I've moved it over to the right.
But since there's two x-intercepts, we have to do this.
We're going to do it twice. Okay, so now I hit enter again. And then I hit enter a third time, and it gave me my 0. So there's my 0 is negative 0.3874. So I've got that written down up here. Negative 0.3874. And we're going to round this to 3 decimals. And we're going to do this again to practice. But let's write that down at least for our answer for right now on our draw board here. So negative 0.0387. Okay, so you might have put the left bound and the right bound in the wrong way. So let's do this again and give you another practice session. Now we're going to do the same thing again, except this time we're going to find where it intersects with over here. So this spot right here. So if we're focusing on this spot right in here, what we want to do is we want to move our cursor somewhat close to that. Okay, so see where my cursor is. When you see the little spider right now is to the left of that spot. Okay? So now what do? We hit enter. Boom. And that all we're doing is we're bracketing it. So we hit enter. And there's that little line that appears that says, okay, I hope our answer is to the right of that line. And you see the little tiny arrow at the top. So now we're going to hit our trace arrow, you know, this little cursor thing here, and we're going to move our cursor. So now it's clearly to the right. Would you say my cursor is clearly to the right of my intersection now? Because I've moved along the parabola, and I hit enter again. Okay, so now let's pause for a second here. So now we have drawn 2 vertical lines, and in the middle of those 2 vertical lines is where the line crosses the x-axis. So those are our brackets. We have a left bound and a right bound. And what's the calculator asking us to do now? Yes. And so move the cursor just slightly. You don't even have to move it hardly at all. Move it just a little bit closer. It doesn't have to be that close. And then hit enter a third time. And now down here at the bottom, it tells us what the exact answer is to 1, 2, 3, 4, 5, 6, 7 decimal places. And so that's what I've written down right here, 1.7207. So we're going to round this to the nearest 10, or sorry, to the nearest 3 decimal places. So we're going to write in our answer as 1.721 because it rounds up. And just going back there to that point, we can flip back here. We're rounding that 1.720 to 1.721. Now, if that was a little bit of a challenge for you, what you have in our notes today is all of those steps, step by step, of what we just did. So here's what you need to do. And by the way, this is Calculator Lab 5.10. Some of you have not yet turned that in. Download that, and that also, just in different language, has you walking through this left-bound, right-bound guess idea again. So I just really want to encourage you to make sure that that is part of our armada of tools. Sean?
When we do this, is this just called finding the zero things?
Yeah. Everything we've been doing this chapter is finding the zeros.
Yeah.
And I'm going to kind of reference that later, but everything we've been doing has been focused on finding where the graph crosses the x and y x-axis. So that's the whole point of what we're doing. All right. Now, that being said, let's take a look at our main focus for today, which is the quadratic formula. It's said that when people do a little bit of singing, it tends to help people, so we're going to do a little bit of singing here to try to get us back in the gear. But before that, we have a little bit of a challenge. Who feels that they are unscarable? Anyone willing to take that challenge? Unscarable. Luke feels he is scarable. Kent? All right, Kent, come on up front. We have a little challenge for you, Kent. We went out into the wild and we found this box. And for years, this box has been known to scare people. Yes. So we're going to have you face our audience here. And you're going to turn this little wheel here. And now you need to put it so it's kind of in front. So you're kind of looking there. This way? There you go. Yeah, look at it.
Yes.
Not bad. Not bad. So pop goes the weasel. All right. So that being said, nice job. Last year, I had Stephen Garrison do it last hour. Oh. Poor Stephen said he was unscarable, and he had a pretty good flinch. But we all know that song, and so I'm going to sing this with us together. We're all going to sing this because when we sing, it tends to help us remember things. So sing with me. It goes like this. X equals the opposite of B, plus or minus the square root, B squared minus 4AC, all over 2A. All right, so we're going to put this little quadratic formula to memory, and hopefully it will help us. But we're going to try to sing this a number of times today to help us make sure that we've got this locked and loaded in our memory banks. All right, so here we go. First one. You'll notice that all of our formulas, I've written our general form of the quadratic formula right there. It has to be equal to 0. Has to be equal to 0 in order to find the A value, the B value, and the C value. So let's take our first equation, and I'm going to change this equation, and I'm going to make it equal to 0. So there we go. We brought the 12 over, and it's equal to 0. Now, underneath that, I would like you to identify what the value of A is, the value of B is, and the value of C. So what's my value of A? 2. B? 5. C? Negative 12. The C value, negative 12. All right, so here we go. Let's write it down. Write down your formula. X equals the opposite of B plus or minus the square root B squared minus 4AC all over 2A. All right, I want you to write that equation down each time you do a problem. And by the end of the homework assignment, you will easily have that mastered. All right, so let's plug these in. The opposite of 5 is negative 5, plus or minus the square root. 5 squared is 25, minus 4 times 2 times negative 12. I'm just trying to get everything under the square root right here. So the first part is I put them all in using parentheses. Next, it's all over 2A. So 2 times 2. Now I want to highlight something here in red. That minus and that minus. We're going to come back to those in just a little bit. But those two minuses together are going to be a key factor in our problem. Aaron.
So if it was minus 5, would you do a negative and a negative in front?
And I have another example later that's going to have that, and it's going to switch it back to a positive. Okay, good question. All right, so here we go. X equals the opposite of 5 plus or minus 25 plus, because that minus times a minus is a plus. 4 times 2 is 8. 8 times 12 is 96. 96. All over 4. All right, so next step.
Did you already square the 5?
Yep, at the very, very beginning. We squared it without, because the 5 was just right there, it's just 5 squared is 25.
Yeah.
All right, so we have negative 5 plus or minus the square root. Let's see, 25 and 96 is 121 all over 4. So I'm going to draw a little line down here. You can go up to the next line. X equals -5 plus or minus. It's nice because the square root of 121 is 11 all over 4. Now we break it up into our two parts. Part 1, -5 plus 11 over 4. Part 2, -5 minus 11 over 4.
Are you done?
I don't think so. What's -5 plus 11? 6. -5 minus 11, -16. So we simplify each one. It looks like we get x equals 3/2 and x equals -4. Now the fact that this gave us answers that were rational numbers means, Greg, that theoretically we could have brought the 12 over and factored. And if we had seen it fast enough, that might have been a faster method. But here's the beauty of the quadratic formula. No matter what the problem is, it always works. Sometimes it's a little bit longer, but it always works. And that's the nice thing about it. All right, so I've created a couple different problems to help us walk through different scenarios. And each of these problems that we have is going to help us to see, well, what about this? Or what about this situation? So let's look at our next one. Here, I have it set equal to 0 already. Kind of.
If it works for every problem, like could it work for 14?
It could.
Okay.
It could. And the benefit is, later in the period, we're going to talk about when it's good to use this method or that method. And that's one of my goals today as we look down the road, is what method to use. I want to make it the easiest possible as I can for you, and that's my goal. All right, so everyone identify what's my A, my B, my C. Write those down. A equals 3, B equals -4, C equals -2. A little challenge for you. I'm not going to sing, but write down the quadratic formula. Go. Write down the exact quadratic formula. We got it. X equals the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Now I need to show you, and I need to teach you a new word that you haven't probably heard since you were in my Algebra 1 class a couple years ago. That B squared minus 4AC is called the discriminant. So if you hear me referring to the discriminant, I'm referring to what's inside the square root. It's just a term. It's no different than saying the key when playing basketball. And everyone hopefully knows where the key is when you're playing basketball. It's that rectangular box right under the bucket. So that's just called the discriminant. We're going to talk more about that later. So here we go. The opposite of B. And Aaron, since B is a -4, I have the opposite of -4. So that becomes 4. Plus or minus the square root of B squared. Everybody, what's -4 squared? 16 minus 4 times 3 times -2 all over 2 times 3. I really encourage you to write those out. It prevents you from making errors that I see over and over and over again. All right, here we go. X equals 4 plus or minus the square root. 16. Now, once again, we have a minus and a minus. So that's going to make it a plus. 4 times 3 is 12 times 2, 24, all over 6. So I have x equals 4 plus or minus the square root. 16 plus 24 is 40, all over 6. And here's where a lot of our problems in Algebra 1 ended, because we didn't create them to go further. This goes a little bit further, so I'm going to come up to the next line here, and I'm going to think, okay, how does the square root of 40 break down? What and what? 4 and 10, yeah, good call. All over 6. And the square root of 4, as you know, is 2. And we're almost done. And now's where we have to do some analysis. Look at the three numbers that are not inside the square root. Those three numbers are 4, 2, and 6. Sometimes each of those numbers is divisible by a number. If they are, you divide. But it has to be all three of those numbers. So, what all three of those numbers in this case divide by?
2.
2. So let's divide them all by 2. So 2 plus or minus 1 square root of 10 over 3. I need you to notice the square root of 10 was not touched. If you wrote your answer like this, it would be correct. You will not see the book Zach writing your answer like this. The book is going to eliminate the 1. That's how the book's going to write their answer. Paul?
If the square root is negative, do we have to have it odd?
Yes, and I have an example coming up that's going to show us that we're going to bring that out. So my examples today is first we did a problem with fraction answers. Second, we're doing a problem with radical answers. And the next one we're going to do naturally is a problem with imaginary answers. Now, before we finish though, it says also approximate to 3 decimals. So you have your calculators. So if you would pull your calculators out, and let's try to figure what this is. The square root of 10 is about 3.16. We add that to 2, and we divide by 3. Please check me on this, but I get x equals approximately 1.721. Can you check me on that? Because you've taken all my calculators. I just have this high-powered one right here.
Yeah.
Is that... No, it's fine. You're good. All right, so let's do the other one. Now we have 2 minus the square root of 10. What did you get for the second one? Point what? I get 3, 8, 7.
I did that. 2 minus
Square root of 10, all divided by 3. So you might want to hit enter, then take that answer and divide it by 3. Now, I'm pretty sure of those answers for one simple reason. I need you to look at this problem and look at the actual problem. And what do you notice? Same as our original one.
It's the same problem.
Yeah. And so we have the same answers as our original problem. And that's just kind of, so we did one of our problems with graphing. And you can do that when they just ask you to approximate to the nearest 3 digits for the ACT. Quick way to do it. Or we can do it with the quadratic formula. So, this green answer at the bottom, that's an exact answer. These answers over here in the box, those are approximations. Pay attention to what the question asks you in terms of how to answer the question. All right, now let's move on, Marissa, to your question about the imaginaries. Our next one. 2x squared minus 2x equals negative 4. First thing I'm going to do is I'm going to bring that negative 4 over to make it a positive 4. All right. Sean or Henry, give me my A, give me my B, give me my C.
A is 1.
Good.
B is -2. C is -4.
Okay, careful on your C. C is positive 4.
That's what I...
Okay. All right, write down your quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I know that seems tedious. I know that seems repetitive. You know the formula right now. You remember it right now. My worry is a week from now, with this repetitive action, it will stay in your brain longer. And I'm hopefully by writing it down and physically saying it as you do it, you're going to remember better. Tyler?
So if we don't do it on the homework,
No, this is not about the homework. This is about learning. I'm trying to teach you tricks to learn. So, do I want you to do in the homework? Yes. Am I going to mark you off? No.
Do we have to?
I'm not going to answer that. All right. Here we go. The opposite of negative 2, 2, plus or minus, negative 2 squared, 4, minus 4 times 1 times 4, all over 2a. Yeah.
Why is it when I put negative 2 squared in my calculator, it turns out to negative 4?
Because you're not squaring negative 2. Your calculator is interpreting that as the opposite of 2 squared. If you really want to put negative 2 in your calculator, you need to put it in parentheses. And then you should get 4. Okay? Good question. That's where we have to be smarter than our calculators. All right, so I've got 2 plus or minus the square root of 4 minus 16 all over 2. 4 minus 16 is 12. So 2 plus or minus the square root of negative 12 over 2. All right, so here we are at the crux of the problem. How do I deal with the square root of negative 12? There's a couple things we need to do here. What's one of them? Paul?
I'm just asking, isn't it supposed to be over 1, 2?
It's over 2a. It's over all over 2a. Does that make sense?
Yeah.
That's okay. Good question.
Would the square root of negative 12 be 2i plus or minus, 2i square root's negative 3?
Yeah, you're a little ahead of me, but the negative comes out as an I. The 12 is a 4, left over 3. You're right.
Okay.
You were just 3 steps ahead of me. Okay, so I broke down the 12 into 4 and 3, and I brought the negative out as an I. And so, just like you said, Kent, the square root of 4 becomes 2. So there's the 2i, there's the square root of 3, and there's the 4. And just to be clear, this 4 leads to this 2. All right? Okay, so the square root of 4 becomes the 2, and we put it in front. Cole and Sarah.
How did you get 4? Yeah.
Yeah, why is there 4?
4 times 3 is 12.
No, down.
On the bottom.
Because I made a mistake.
Hey guys, come on, right?
Thank you. All right, now, was that your question, Sarah? Good catch. Thank you, guys. I was so focused on the square root of 4 thing that I was just thinking fours. All right, I highlighted the 3 numbers out front. Do they all divide by the same number? Yes. What do they all divide by? 2, giving us 1. You're already saying the answer. You're just like me, Danielle. So my answer is 1 plus or minus 1i square root of 3. What is the book not going to write? The second 1. So erase that. And there's my answer. They're not going to write this 1 right here that I'm writing in red. That 1 is not going to be ever written in a solution guide. It's just going to be I root 3. Marissa?
So whenever there's like a square or complex with the I, we don't need to solve it or anything.
Well, you have to simplify
I
it
would
here.
just simplify, we just don't have to solve it like going.
You can't solve it.
Yeah.
That's as far as you can go.
Okay.
All right, so let's kind of look at this one for a sec before we move on. Couple things to pay attention to. Bringing out the I, reducing the 4, and then canceling those 3 numbers in yellow. So those are a couple of the little issues that are highlighted there that are common errors that I've seen. Now, let's do a little review now. We've kind of done all the new stuff. Now we're going to kind of weave this all together, chapter full, and bring everything to a piece. So let's look down here. The exact same problem, we're going to complete the square. So this is a review of section 3. So put in the plus blanks. What goes in my blanks and why? Remember, we're saying half of 2 is 1, and 1 squared is 1. So we put a 1 in each blank. All right? Negative 4 plus 1 is negative 3. Do what to both sides? Square root. When you take the 2 square roots, you have 2 answers. So there's your plus or minus. Yes. Plus or minus I square root of 3. Do you understand why Danielle said that? Where did the I come from? The negative. And on this side we have x minus 1. So how do I solve this? Just add the 1. 1 plus or minus I root 3.
Can you put up the, like, in front of the back,
Put up the what?
the 1,
Uh-huh.
put that at the back, would that be wrong?
Do you mean put it like this? 1 plus or minus root 3I? Or are you saying plus or minus I root 3 plus 1? Both of these are right, but they're never written that way because our standard form is A plus BI as a standard. So that's just typically how we write a complex number. So here's our answer. Now, I want you to compare these two. We have completing the square and the quadratic formula. We did the same problem in two different ways. In my opinion, the completing the square for this case was much easier. That will not always be true. The reason this completing the square was easier was what kind of number do we have for our linear term? And I'll highlight it. What kind of number is that? Even. What happens if we have odds like we had here? Completing the square becomes, Paul, a little bit more challenging here. Okay? But when it's even, it makes a whole lot more sense.
I have a question.
Yes, ma'am.
Wait, are we done with that?
With this one, yes.
So, are you supposed to get the same answer for...
We should, and we did. Okay? Both of these two answers, both of these two are the same. See that? Yeah, so both of those two should be the same answer. So I'm going to erase these over here, Sarah, just because those I don't really want to have those be even thinking of we should be writing our answers like that. So, all right, let's move down to the next one. We're going to take this same problem and we're going to practice again. Now we're going back to section 3 and we're going to write this in vertex form. So this is back to section 3. I'm really trying to weave in review for you. So if you remember, we moved the constant over as our first step. Our second step, we put in the plus blanks. Our third step is we identified what goes in the blank. Well, that's negative 1 squared, so that's 1, just like we did in the previous problem. So we have y minus 3 equals x minus 1 squared. And to put it in final vertex form, we have x minus 1 squared plus 3. Is that familiar? That was just a couple days ago when we did vertex form, probably last week. All right, so we're going to take this now and we're going to review how do we graph from vertex form. So I'm going to recopy it right here, x minus 1 squared plus 3, just bringing that straight down to here. So here we have our problem. Who can tell me my vertex? Danielle? 1, 3. Do you notice how she has positive 1, 3, guys? So everyone graph 1, 3. What is my axis of symmetry? Could you draw that in, please? Draw in your axis of symmetry. And then tell me what the equation of that blue dotted line is. It has a variable. What variable? X. What does x equal? 1. Yeah, x equals 1. Can anyone recognize what pattern is on this parabola? Over 1, up 1. Over 2, up 4. So let's do that. Over 1, up 1. Over 2, up 4. Can I do the next one? No. It's off the graph. All right. Now, do you remember that the y-intercept is the point 0, C from up here? Does that ring a bell? What is the value of C? 4. So this is our check. This is why this is a great thing. I'm going to put that green dot right there. Is that the same dot as we got as from the 1-1 pattern?
Yeah.
That's our check. That's how we know, Tom, that we got this right. Because our C value agreed with our graphing vertex form. And that's how you know when you're doing these problems that you're right. So we can do our quick sketch here. And we have our parabola. I think there's one more question that a parabola question like this would ask you, and it is the vertex a max or a min? We all agree it's a min. Okay. All right. So I think that's all the possible questions that you could have about this particular problem. Now I have one more that I want you to pull out. Tell me, does that parabola cross the x-axis? It's a rhetorical question. What's the obvious answer? No. Now, I want you to scroll up here and tell me our answer is 1 plus or minus I root 3. That's a complex number. And you remember, Paul, I told you complex numbers don't exist on a number line. So that's why when you see a complex number, what you know, Cole, is the graph doesn't cross the x-axis. It still has solutions, they're just complex. They're just 1 plus or minus I root 3. So that's a little hint for you. It's like, wait a minute, my graph crossed, but I have eyes. It shouldn't be both. If your graph has eyes in it, then it shouldn't cross the x-axis. So if we just look at this graph in general, there's a lot of different graphs that would have answers that were imaginary. So anything like all of these are all going to have imaginary answers because all of those graphs in blue don't cross the x-axis. We're not going to worry about those right now, but I wanted to kind of hit that as an important key idea. All right. Trying to review as well as do some stuff. Now we're going to get to kind of the final summary here of what method to use and when is it best to use a certain method. What's the easiest method to use? So let's kind of over here at the right-hand side, tell me a method that we used this chapter to solve a quadratic. Someone tell me one method. Okay, we used completing the square. All right, so complete the square, which is really vertex form. Completing the square, I will tell you, is easiest when the x term is even. If this was the problem over here, x squared minus 3x, I would not complete the square unless I was forced to. So that's a little hint, when to use completing the square. All right, someone give me another method we've used this chapter. Kylie. Factoring. I would call factoring the 30-second method. If you can't factor the problem in 30 seconds, skip it and go on to another method. But many methods you can now factor in 30 seconds. And think about factoring versus the quadratic formula or completing the square. A whole lot easier, right? You factor, you solve, you're done. So that's good. Give me another method that we've done this chapter. We just did it. Paul?
Quadratic.
Yeah, the quadratic formula. The quadratic formula. And I would say when all else fails, that's when you use this. All right, there's one more method that we haven't talked about. We did it a couple days ago. Taking the square root of both sides. And you're going to take the square root of both sides when you have no linear term. Do you guys remember what a linear term is? The x term. So there's just an x squared and a number. but no x term. That's when you're going to take the square root of both sides. And so this little methods to solve, I think, will be a nice thing for you to have if I was kind of doing a summary of this chapter. This methods to solve is probably a summary of everything that we've done in this chapter for solving quadratics. So let's look at this first one. You have 4 methods to choose from. Off the top, does this thing lend itself to completing the square? No. Is there a linear term? Yes. So we're down to either factoring or quadratic formula. You want to spend 30 seconds?
Let's do it.
All right. What must the sign be, Sean? I'm putting you on the spot.
I'm pretty sure it's plus minus.
Plus minus, okay? If you disagree with Sean at any point, feel free to holler. Plus minus, he says. Sean, what must be the front numbers to get 5x squared?
Would it be 5x?
Mm-hmm. All right. I've got to get a 6, Sean. So that's 1 and 6, 2 and 3. Which one do you want to try?
Let's go 2 and 3.
Okay, so 2 and 3. 5 times 3 is negative 15. 2 times x is 2. Did that work?
Yep.
Okay, so we have it factored. Let's set each factor equal to 0. Let's solve. So x equals negative 2/5. X equals 3.
Wait, where'd you get negative 2 if it's-
Subtract the 2 and divide by 5.
Oh, I forgot the negative sign.
So, Sean, 30 seconds. You've got the bulk of the problem done. Much easier. I want you to imagine, guys, the quadratic formula for this. It would be the opposite of negative 13 plus or minus 13 squared minus 4 times 5 times 6. You're talking some large numbers inside that discriminant. Remember the discriminant, guys, is the thing inside the square root? Okay? So, I would certainly try to factor this one. And it worked. It's not always going to work, but it's worth 30 seconds of trying. All right, next one. What do you notice about example 5? Tell me what you notice.
No linear term.
Okay. There's no, what? There's no constant. Do you remember what we do when there's no constant? That leads to this, GCFs. What's the GCF here?
2.
Yeah. Take out a 2x. Good catch. What's left?
X minus 5.
X minus 5. So, I forgot, because it's kind of in the factoring. In my world, it's in the factoring part. So if you want to kind of say, hey, this is also part of factoring, it's kind of in the factoring world, really. So I have 2x equals 0, x minus 5 equals 0. So x equals 0 or x equals 5. Now, some people said, could I do this with the quadratic formula? You bet. A would be 2, B would be negative 10, C would be 0. Could you? Yes. But it would work. I have some students say, I'm just using quadratic formula for everything. I'm like, go ahead, it's fine. Your homework might take you a long time. But it'll work, right? All right, example 6. What do you notice about example 6?
No linear term.
There's no linear term. So what's the best method?
GCF.
What do we do when there's no linear term?
Can we not GCF it?
We're going to, yeah. Take the square root of both sides. Okay, so to solve a problem by taking the square root of both sides, you're going to isolate the x squared. So x squared equals negative 5 in 2 steps. Now you know how to solve that. What do we do? Take the square root of this. Remember, with 2 square roots, you have 2 answers. All right, so who can give me my answer? Someone who hasn't been jumping in here yet. Joey, maybe? Karen? Aaron? What do we do with the negative? Make it into an I. There you go. That's it. Now tell me, does this parabola cross the x-axis? No. How do you know that? It's a complex number. All right. Now, something a little bit different today. I have two options for you for homework. This was suggested to me by somebody. I'm going to kind of try to start doing this for you. The first option, which is purple, is kind of normal problems in the A section. If you're kind of a regular student who likes to just kind of work through the basic problems in a progression like we did in our notes, that would be good for you. If you're more of an advanced student and you feel like the problems that we're doing are not challenging you, to be very honest, and you want to be pushed a little bit more, you might want to move into option 2. Okay, option 2 are problems that are primarily B-level problems. All right? There's not as many B-level problems, but they're a little bit more difficult. They're going to push you mentally. You don't need to do either. You don't need to do both. Just do either purple or blue. Now, on the purple, 51 says challenge. That means it's not required. But it is a challenge. So even if you're at the kind of working on the A-level problems, it's a good challenge problem. That make sense? You don't have to do it. Does that make sense? Will that help a little bit? I'm just trying to see, I want to give some of you a chance to be challenged a little bit more, and I want to give others of you a chance to kind of work the normal pace that we normally do. So